I want to start the Explore by fixing something on the warm-up. Right here, I added, I moved down, excuse me, I moved down a 3 instead of an 8. So that was negative 5 times 13 times 8. Negative 65 times 8. So negative 65 times 8 is negative 520. That's what the key says. Okay. All right. So for Explore, we want to talk about identify, evaluate, add, and subtract polynomials. So what is a polynomial? Polynomials are made up of terms. Terms are the product of numbers and or variables. Each term in the polynomial has a numerical coefficient and a degree. The numerical coefficient is the number in the front part of the term that is multiplied by the variable. So if you have a 5x, that's the numerical coefficient, that's the variable. Together they make a term. You can even call them a type of polynomial term. I would go with variable term. If they have another term next to them, this is a polynomial term. The degree is referring to the exponent of the variable. So this would be a second degree polynomial because that's as large as the exponent goes. The constant terms are the terms that don't have any visible variable. If there was an x here, this would be a 1, this would be a 0. See how they go in numerical order as far as exponents go? This is the leading term. That's why it's a second degree polynomial. It's also considered a trinomial. There's a lot of names for these things. The term polynomial itself means many terms. Monomials are 1, bis are 2, tris are 3. Expressions with more, we just call them polynomials. Okay? They're written in descending exponential order if they were put in order. Sometimes there may be gaps when exponents are missing, as in if you have 3x squared plus 3, you're missing an x to the 1. That doesn't mean it has to be there, it's just missing, okay? So that's what they talk about, the gaps. The first is called the leading term, containing the largest exponent, and it's called the leading degree. Polynomials are named by its leading exponent. So a third degree polynomial starts with a cubed variable. So if there was a 4x to the third in the front, this would now be the leading. It's a third term, third degree polynomial. Its leading term is 4x cubed. Its leading numerical coefficient is a 4, a positive 4, okay? So here is a fifth degree. It's out of order. I did this on purpose because your homework doesn't ask it in order. It just says, as it sits here, what's the first term? The first term is x to the fourth. The degree of that is a 4 because that's the exponent. Its numerical coefficient is a 1 because you don't see anything in front of it. Okay? The second term is a negative 9x to the fifth, so it's a fifth degree. Its numerical coefficient includes the negative, so negative 9. The third is that one. It is a third degree. Polynomials, don't have negative exponents. It is a negative 6 for the numerical coefficient. The fourth is 5x. This is 2. All right, the fourth term is 5x. Its degree is 1. You don't see an exponent, right? These are exponents. The number in front is a positive 5. The fifth term is a negative 2. Its degree. Think about it. This is a 1. The 2 is missing, so this is a 0 degree. with a negative 2 as a coefficient. Don't forget that negative. So it'd be nice if you put things in descending order. So let's see. If this had to go in descending order, that's the leading term. So once it's in order, we can talk about that being the leading term, that being the leading degree, this being the leading coefficient. Okay? That's a 4. So the next one is a 3. Then there's a 2. Make sure you take the negative with the negative. Then there's a 1, and there's a constant term. Okay? So there's no missing here. There's no gaps here. All right? When you write these down, hang on. Uh-oh. Hope my pen isn't dying. Could be dying. There we go. Ah! Yeah. Oh my gosh, sorry. All right, so that's where you're going to see. You're not going to see the 1s and the 0s, but they're there. So the second term is negative 7x3, which makes that a 3, which makes that a negative 7. Third term is 9, 2, and no, it's not. 9. I'll slow down. 9. Okay. Fourth term is just an x. It has a degree of 1. It has a numerical coefficient of 1. You just don't see it. The fifth term is a constant term because it has a degree of 0 and a numerical coefficient of negative 8. Remember, that's that. You just don't see it that way. That plus, that is really a 1 and a 1. Okay? So sometimes they ask you to give a replacement value. So they'll say, here's your polynomial. It's a trinomial. Its leading term is negative x squared. Okay? It says, okay, let's put in a 3 for x. What do you get? I like to keep them in parentheses, and then you follow order of operations. So orders of operations says, do this first, so that's your 9, times 1 is a negative 9, times each other is a 6. You add them all together. 12 minus 9 is 3. Okay? Number 2 says, here's my trinomial. Put a negative 4 in. This is why I like the parentheses. Look at this right here. So negative 4 times negative 4 is a positive 16 times 2 is 32. Negative 4 times a negative 4 is a positive 16. The 6 didn't get touched. Now we add them all together. And let me just check that. 32 plus 16 plus 6 is 54. All right. Here's one here. Negative 11. N is a negative 1 to the third. Minus 9. Negative 1 to the second. Minus a negative 1 minus 5. Oof. Okay. So 11. Let's see. Negative 1 3 times is going to give you a negative 1. Put that back that way. All right. Negative 1 times negative 1 times negative 1 is a negative 1. Negative 1 times negative 1 is a 1. And a negative 1 times a negative 1 is a 1 minus 5. Okay. Negative times negative is a positive. Negative times 1 is a negative. Plus 1 minus 5. Add that all up. We have negative 14 and a positive 12, so a negative 2. Okay. Then sometimes it'll say evaluate, add and subtract polynomials. Okay. When you're adding, it's the parentheses are just extra. It just says here's a trinomial plus a trinomial. That's all it's saying. So it doesn't help with the math to have them there. You just need to go find like terms and add them. Whoops, that's not a like term. Hang on. Where's the second? That's a second. That's 1, and then this one and this one get together for that one. Okay? When you subtract this trinomial from this trinomial, it's the same as distributing a negative 1 to every term in here. So these parentheses come off the front one because I didn't really need them. And then as we distribute, we take that off. So the first term goes from positive to negative, the second term positive to negative, third term negative to positive. Then you go and find like terms, add them together, and you get that. Those are not like terms, so that is your final solution. All right, this one here, let's see, that's all positive, as in it doesn't have, it's not raised to a power, it doesn't have anything next to it. I'm just going to write it down. This is not a negative, so this can just be all mashed together too. But then this one is a -1 that needs to be distributed. So negative x squared. Negative is a positive. Negative is a negative. All right, now 2, 2, 2. 7 minus 1 is 6. Right here. Right here. Right there, that's a -10 plus 9 is a -1. And then that one, and that one, that's a 4 minus 8 is a -4. No gaps. That's your leftover. Okay.